Okay, welcome to Financial Computing 2 in Mini 3 of 2022. We, in this class, are going to be doing C++ programming, and we're going to be doing that using the Microsoft Visual Studio Code editor and development environment in a Linux environment installed on Windows 10. Or you can also use the native Unix environment on a Mac. In this video, I'm going to be talking about how to install this necessary software under Windows 10, and I will also provide some written instructions if you happen to be using a Mac instead. And these written instructions are stolen and edited from the instructions that Professor Kramkoff has put together for his Financial Computing 3 and Financial Computing 4 courses, in which you will also be using the same environment. Okay, so there are basically 4 steps, and here, by the way, I'm following along with the written instructions that I've put together for installing this software under Windows 10. So in Windows 10, we're going to need to activate something called the the Windows System for Linux. Once we have got our Windows System for Linux activated, we're going to install Ubuntu Linux as our version of Linux within that Windows System for Linux. Then we're going to be using the Free Software Foundation's GNU C++ development environment tools. Finally, as our text editor and our integrated development environment, we're going to be using Microsoft's Visual Studio Code within the Ubuntu Linux environment, making use of these GNU C++ tools. So, the process for setting all this stuff up is long and tedious, and I urge you to do exactly what I have written and exactly what I am saying in this video. Don't try to take shortcuts. Be careful that you haven't skipped any steps. It will be exceedingly painful if you make mistakes or forget things and have to uninstall everything and start over again. All right, so the first thing we're going to do is to activate the Windows System for Linux, WSL. And you can see this as step 1, starting on page 2 in the instructions. So we do this from the control panel. You can just type control panel in the search box and next to the Windows menu button. And here is the control panel application. All right, what we want is under Programs, so click Programs. Be careful not to install, be careful not to click uninstall a program. You want to click Programs itself. Then look for Turn Windows Features On or Off. That's what we want to click next. And we get this menu of things that are either selected or not selected. And way at the bottom, you'll find Windows Subsystem for Linux. Now, on my system, it is activated. On your system, if that checkbox there is empty, you're going to want to click that checkbox and then click OK. In my case, since it was already activated, nothing happens. But for you, if it was not already activated, you'll get a screen asking you if you want to reboot your system. And at that point, you must reboot your system. Now, you can and should close all of your other applications first before you say that you want to reboot your system. Okay, so go through the reboot process, wait for your system to come up, And then we'll be moving on to the next step, which is to install Ubuntu Linux. There are many releases of Linux. Ubuntu is one of the most popular ones. And this is step 2 in the documentation, starting on page 4. What we're going to do now is to open the Microsoft Store. You can do that by dragging down in your Start menu. Here is Microsoft Store. Or you could just type Microsoft Store in your search box there. Okay, and here is the Microsoft Store. Now, it's going to look a little bit different depending on what is being advertised for you when you launch the store. But up here in the search box at the top, we're going to type Ubuntu. And then just hit the Enter key. What you get here is the most current version of Ubuntu Linux. On my system, it's already installed, so all I have to do is open it. On your system, it will probably need to be installed. And so instead of having an Open button, you'll see an Install button. Go ahead and click Install, and it will take a few minutes for that installation process to take place. When that installation process is finally over, then you can click Open, and this will open an Ubuntu terminal window on your screen. Now, I have already installed Ubuntu Linux on my system. On your system, instead of a white window with black text, if you take a look at the documentation on page 5, you'll see that you'll get a black window with white text. And the first thing you're going to be asked to do is to enter a new Unix username. Okay, so I'm going to just kind of simulate that here. So you're going to see something that looks like enter new Unix username. You can choose any valid Unix username that you want. How do you know what is a valid Unix username? Well, turns out that Android IDs are valid Unix usernames, so I strongly urge you to use your Android ID, okay, as your username. Now, when you hit the okay, so for me it echoed, which is not what I had in mind. Let me kill this off and try again. So I'm going to do something called redirection of cat. All right. Enter new Unix username. You don't have to worry about what what trickery I'm doing here with cat. I'm just trying to show you what you will see on your screen. All right, so you enter your new you enter your new Unix username, preferably your Android ID, and you will get asked to enter a new password. So here you should type some reasonable password. Maybe your Andrew password is fine. And when you type it, you won't get any feedback at all from the Ubuntu password setting software. So this is unlike if you're logging into a Windows box where you can at least see that you're typing characters. Here you're not going to see that you're typing anything. But when you hit the Enter key, you will get asked to retype the new password. And so you need to retype that new password again. And assuming you succeed, you will then get a message, and this is all shown on page 6 of the installation documentation. You get a message saying installation successful, and then a whole bunch of noise, blah, 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 blah. And down at the bottom, you'll get home slash your Andrew ID. So for me, it's jostland slash dot hush login file. Okay, so that's just some text that gets displayed. And then you will get a prompt waiting for you to type your next command. Now, the problem here with the white text on a black background is that most of that prompt is going to be invisible to you. All you're going to be able to see is a colon and a tilde sign and a dollar and a space. Okay, so that is your prompt, and the cursor will be sitting there after that dollar sign, waiting for you to type stuff. What you need to do next is to go to the title bar at the top of your window and modify the window so that you can actually see the prompt, and so that you can see other things that you ought to be able to see. So if you go up to the title bar and right-click, you will get this menu, one choice of which is Properties. So we're going to select Properties, and we have Options, Fonts, Layout, Colors. We want to look for colors. Select Screen Text and make that black. You can click on this black box here to make it black, and you'll see that all the RGB values, red, green, blue values, get set to 0 for the text. And then go to Screen Background and click on the white box. So red, green, blue are all on. And now when you click OK, what will happen for you is that just the very bottom part of the text being displayed will come out in black text on white background. And what you're going to see is your machine's name. Now, this is your Linux machine's name, and it's just basically kind of made up, so you don't need to worry about it. The prompt is going to consist of your username and then an @ sign and then the name of your machine. And for me, Ubuntu just created this name, Jostle131726. Okay, that's the text that you couldn't see when what was being displayed on your screen was white text on a black background. Okay, so now you can see the prompt. And in fact, if you now clear the screen by typing CLEAR, for those of you that have worked with terminals in MS Windows, the equivalent command there is CLS for clearing the screen. Here, we type out the word clear and hit enter. And although I can't really do it here, that will clear your screen. And all you'll have is this prompt up at the top of an empty screen. All right, I guess I can get that by killing my cat command and then doing a clear. All right, so that's where you should be at this point. Okay, so you have now successfully installed Ubuntu Linux. The last couple of things you want to do are to make it convenient to access this terminal. So go to your Start menu, locate Ubuntu, which should be in your recently added collection up at the top, and you can say right-click and pin to start. Now I've already got Ubuntu pin to start. And you can say more, pin to taskbar, and I already have Ubuntu in my taskbar. So you can have easy access to this Ubuntu character terminal either in your start menu or in your taskbar or both. All right, once you're done with all this stuff, you can close the Ubuntu terminal, close the store, and at this point, once again, you should reboot your system. And after you have finished rebooting your system, you're ready to move on to step 3, which is described starting on page 9 in my instructions. This step is going to bring the Ubuntu system up to the most current release and also install the GNU C++ compiler and debugger. Okay, we're back. So I have successfully restarted my system and restarted my recording. Now I want to move on to the third step here, which is described in my written notes. What we want to do now is to bring Ubuntu itself up to the latest and greatest release, and we're going to install within Ubuntu Linux the Free Software Foundation's GNU C++ tools that we're going to need for our course. All right, so let me start the Ubuntu terminal by clicking my icon in my taskbar. And here we are. All right, so the $sign here is a visual cue that I'm looking at a shell prompt. And in this shell prompt, not that it matters that much, the default shell prompt consists of your username and an @ sign, and then your machine name. So my machine name is Jostel131726. I don't remember how I set that up. It may just be the default that Windows gave me when I installed Windows years ago. This tilde here is actually meaningful. That is the shorthand notation in Unix and Linux systems for the home directory. So this would be like your /users / whatever your name is directory in Windows. All right, so I've got my Ubuntu window up, and I now need to execute some configuration things. Let me move my Ubuntu window up a bit and shrink it, and then I'll move my MS Word document down so that we can see everything here. Okay, so in a Windows environment, the user account that has the ultimate power to do anything that needs to be done is administrator, okay? The equivalent thing in a Unix or Linux system is called the superuser. All right, so the superuser is the user who is allowed to do absolutely anything on a Unix/Linux system. The name of the superuser account is always root. Not that that really matters to us. We, as an ordinary user, can gain temporary superuser privileges through the use of the sudo command. That is sudo. Sudo stands for superuser do. That is, as the superuser, we're going to do a command. And by default, the first user account that's created on the Ubuntu system is automatically granted the ability to use sudo. So first of all, we're going to use sudo to make sure that our Ubuntu system is up to date. This is going to take a few minutes. Let me hit the enter key and let it go. I also need to type my sudo password. Now, this is not the superuser password. This is my J. Ostlund account password, so I'd better remember what that is. All right, I'm going to type in my own password here, and okay, so we go out to the web, and we're going to test the update status of a whole ton of packages in Ubuntu. And I'll probably clip out some of the time here. Okay, so we get told after a minute or so that there are 156 packages that can be upgraded. And to do that, we will run sudo again, sudo apt upgrade. Okay, so we did the update. Now we're going to do the upgrade. Do you want to continue? I'm going to say, yes, I want to continue. And this likewise is going to take some time. Okay, well that took something like 5 minutes, but it looks like we're finally done with just updating and upgrading Ubuntu itself. Now we're going to install 3 tools or packages of tools that we need for doing C++ development. The GNU C++ compiler, which is called G++, and the GNU debugger, GDB, as well as CMake, which is... come back here. All right, I'm going to track this down. Here we go. All right. So, G++ is the compiler, GDB is the debugger, and CMake is a configuration tool that we'll talk about a bit later. So let's get these guys done. Sudo apt install G++. Do we want to continue? Yes. This takes a little while, but not nearly as long as Ubuntu itself. Notice over here on the right, it'll tell you that there are 37 seconds left to get this installation done. Although that may actually be 30 seconds, 27 seconds left for the downloading, then it's going to take a little bit of time to actually do the installing as well. All right, so that ended up taking a little bit over a minute, I would say. That's G++. Now we're going to do a superuser do apt install GDB. This one's quick. All right, so that's it for GDB. 20 seconds, maybe 30. And finally, sudo of apt install CMake. Another quick one. Okay, probably about 30 seconds or so. All right, so we've now, hopefully, got our C programming tools installed. We need to check that they are installed by executing each of these 3 commands, G++, GDB, and CMake, and we can simply ask for the version of the installed program to make sure that the program is actually installed. So if I say G++ -- version, Okay, it must be installed. I get told that this is copyright the Free Software Foundation. And this is version 9.3.0, so that's good. I mean, I assume that's good. It is installed, and that's that's fine. So I'm going to also do gdb dash version. Okay, it is also installed, and cmake version, and it is also installed. So all three of these things that I need are installed. Okay, so let me interject a confession, which is that business about installing Ubuntu and GNU was from last year, but it's identical to this year. The main difference that you'll see is that the version numbers are updated. So G++ is at version 9.3.0, GDB is at version 9.2, CMake is at version 3.16.3. But other than that, everything is the same. If you got indications that something was not installed, you would need to go back and re-execute one or more of these sudo apt install commands. All right, so we've got our C++ stuff now. So our next step is going to be to install and configure Visual Studio Code. All right. So in a browser, we're going to navigate to the visualstudiocode.com website. In fact, I can simply press Control and left click to open that website. Here it is. And what we're going to do now is click the Download for Windows button. It is also possible to download for Mac, or to download if you have a native Linux system. But of course, we're using Windows 10 here, so we're going to click Download for Windows. I am using a Chrome browser, so when I click Download, what I'm going to see in the lower left corner here is the setup program being downloaded. It's stopped flashing now, so the download must have finished. And I can show this program in my folder. Now, of course, if you're using a different browser, how you get to that program after it's been downloaded will be slightly different. But here is my setup program. Actually, the most current version of VS Code is version 1.63.2, not the particular version shown in this video. And I want to double-click that program in order to launch the Visual Studio Code setup program. All right, double-click. And here we go. So let me get back to my instructions. I can close my Windows Explorer, my File Explorer, and I can close my browser and return to my instructions. Okay, so I first want to accept the agreement and click Next. Then I'm going to select a destination location. I'm quite satisfied with the default, so I'll click Next. Select the Start Menu folder. Again, I'm fine with the default, so I'll click Next. Select additional tasks. I don't really care about having a desktop icon, and I don't really care about associating file types with Visual Studio Code. So I do want to have Add to Path checked, but the other ones I will leave unchecked and click Next. All right, so now we are ready to install. So we'll just click the Install button. Whoops. Come back here. There we go. Okay, so there's my Install button. I'll click Install. And this takes a little bit of time, not too long. Now, I don't want to launch Visual Studio Code quite yet because I want to set up my start menu and taskbar icons. So I'm going to uncheck Launch Visual Studio Code and click Finish. All right, so we're down to here now. So in the Start menu, I'm going to notice the Visual Studio Code's icon has been added as a recent program. I'm going to right-click that and pin to Start. All right. So now I've got it in my Start menu. I'm also going to right-click that icon and use More and pin to the taskbar. All right, so now I can access the thing conveniently. Now I want to launch Visual Studio Code, which I can do by clicking my taskbar icon. Here we go. Now I want to actually expand the size of the text here. So let me change this to, well, that's part of what I wanted to do. But I want to, how do I get back? Oh, okay. I pressed F11 and that shrunk my window back down to regular size. So let me go to View and Appearance and zoom in. I think I want to do a zoom in a couple of times. All right, that looks better. And now I'm going to, there we go. That's a little more readable. Okay, so next up we need to install various so-called extensions to VS Code so that we can write programs using our Ubuntu environment that we've installed. And the first of these is we need to click the Manage icon. That's this gear symbol over here in the lower left corner. And choose Extensions. There we are. The next thing we're going to do is search for, and I've already done it there, so I cheated a little bit. Search for WSL. And at the top of your list, you're probably seeing Remote WSL. We need to install that so that our Windows file system can communicate with the Linux system. All right, so we click Install, installing. That was quick. Okay. So WSL lets you run a Linux environment. Well, we can edit files in Linux using Windows-based tools. You can't easily run or debug, blah, 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 blah. Okay, so there's all this stuff here. Next up, we need to locate C++, C++ IntelliSense, and make sure that those are installed. So let's do a search for C++. And all right, so here we have C++ version 1.7.1. We're going to install this. All right, so it's installed. So next up, we need to install CMake and CMake tools. So let's do a search for CMake. And here we go, CMake and CMake tools. So we'll install CMake. And we will install CMake tools. Okay, so now we can close Visual Studio and close our Ubuntu terminal. All right, so let's close Visual Studio Code, and we're also going to close our Ubuntu terminal. Okay, now we're ready to move on to step 4, which is... Oh, that was step 4. Okay, so now we should be ready to go. All right, so we are now ready to take a look at creating, compiling, and executing our first C++ program. We'll start out by launching an Ubuntu terminal. We're going to create... Well, actually, first of all, let me show you the ls command. The ls command lists the files in your current directory, and since I just got a prompt back, that means that I don't have any files or directories yet in here. I want to create, using mkdir, which is, similar to the Windows command, or actually vice versa, since Unix predates Windows by a couple of decades. I'm going to create FC2 as the directory for my course materials, for my exercises and experiments. Now if I do ls for list, I see that I do have a directory named FC2. The color here tells me, or it gives me a hint, that it is a directory because it's in blue. I can change directory into FC2 using the cd change directory command. Notice now that the prompt is updated to tell me where I am located now. Okay, so now I am in my FC2 subdirectory underneath my home directory. And by the way, you can get what's called the full path name of your current location in the directory tree using the pwd print working directory command. Okay, so my home directory is /home/jostland, and I am currently in the FC2 subdirectory underneath my home directory. I'm going to create another level of subdirectory called prog1. And it's in this prog1 directory that I want to create my first program. Okay? So, now I am ready to run Visual Studio Code from within this Linux environment. I do that by using the command code and prog1 as the directory containing my project. And the first time I do this, some downloading occurs. Chug, chug, chug. And there we are. So now I have Visual Studio Code running within my Ubuntu environment. Notice I get this nagging message at the lower right. You're currently using WSL1. We strongly recommend upgrading to WSL2 for improved performance. Frankly, for our purposes, for this course, the improved performance is not really relevant, and it's a lot simpler to just stick with WSL1. So I'm going to click Don't Show Again here. I get this annoying security thing. Do you trust the authors of the files in this folder? You might or might not get that message. I am going to click that I do trust the authors of all of the files in this folder. I'm the only person on this machine, and I'll click Yes, I trust the authors. I also want to mention, if you're looking at this choose the look you want stuff, and you just want to get on with business, you can always go up to the Help menu and click on Get Started, and that will get you back to the Get Started screen. All right, now we are ready to create our first program. I'm going to say File, New File. The file is untitled. And the very first thing I'm going to do is to say File, Save As, to give this untitled file a name. And the name I'm going to give it is hello.cpp. And click OK. Okay, so now I have a file that is empty called hello.cpp. Actually, technically this file exists, and all it contains is a blank line. So it contains one new line character. That's all this thing contains. I'm ready to type in my C++ code. Do you want to install the recommended extensions for C++? I already did that. Let me see what the recommendations are. C++ for Visual Studio Code. It's already enabled. All right, so I guess I'm just being annoyed here. Let me close that window. All right, so I was getting a redundant message. Actually, it looks like I should click this Install in WSL Ubuntu button, so I'll do that. All right, well, sorry, that was annoying. The text here is very small, so I'm going to return to the View menu and zoom in a couple more times. I'm also going to narrow down that left-hand. Come on, appearance. Zoom in. All right, there we go. And now I'm going to type my very first C++ program. If you look in a typical introductory C++ programming book, this is essentially always the first program that people use with tiny variations. I'm going to say include IO stream. That statement pulls in some interface information about the standard input-output stream for reading and writing character streams or character sequences. If I forget to use that include of IO stream, then later when I attempt to create output to the terminal, that will fail to compile. All right, so for now, just treat that as required boilerplate. The next thing I'm going to do is to define a function named main. And this part here, main, is the name of the function. Following main, I have to have a pair of parentheses to indicate the parameter list that main receives. For now, that list is just empty. And according to the standard, main should always return an int value. So I've said int in front. And of course, that's very similar to the Python int. It is a discrete integer value. The body of main is contained within a pair of curly brace characters. So when I hit one curly brace, it automatically fills in the closing curly brace for me. When I hit enter, the editor splits those out and gives me an empty line to type on. I want to create a simple line of text on the screen. And so what I do is say std : C out. Okay. C out is the standard output stream object. And C out is part of the standard C++ library. And that's what this goofy notation says. I want to use the C out object that belongs to the standard library. And into that object, I'm going to insert, the double less than symbol here means the insert operation. And in double quotes, I'll say hello world. And a new line. Whoop, 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 whoop. I hit enter by accident. And a new line. Now, in Python, we could use either single quotes or double quotes, or for that matter, triple single quotes or triple double quotes to define a string of characters. In C++, we can only use the double quotes. And unlike Python's print function, when I insert a string into the standard output object, cout, I will not automatically get a new line by default. So if I want a new line at the end of my string, I have to specify the new line character with \n. The last thing I need to do here is to type a semicolon. The semicolon in C++ is the so-called statement terminator character, and it's simply required at the end of each statement such as this. If you leave the semicolon out, you'll get an error message. In modern compilers, you will often get an accurate description of the problem, which is that you forgot your semicolon. In older compilers, you would just get an error that wouldn't necessarily help you figure out what you did wrong. Okay, so I'm going to insert this string into the cout standard output object, and that will cause the string to be displayed on my screen. Main returns an int, so let me use a return statement, and it turns out the value 0 indicates success. That is, that so-called exit code or return status of 0 is passed back to the Unix system, or Linux system in this case, and 0 is how a program indicates to the system that it succeeded. All right, well, that was a lot of jabbering, but now we're done. I'm going to save this file, and I can go up here and say run without debugging. I'm asked to choose what variation of C++ I want to use, and I want the GNU version, the one that has GDB. I don't want the Windows version that I may or may not have installed. So I'll click the C++ GDB, and I'm now given various choices of compiler program. I want to use the G++ GNU C++ compiler. That's the first choice. So I'll click that, and poof, it automatically, the Visual Studio Code automatically constructs this launch.json file, which it then passes on to the underlying compiler. I see here that the program hello exited with code 0. Okay, that's the exit code that I specified in my return statement, so that means that the program did successfully run, but I can't see the output unless I look at the terminal, okay? So in this lower part of the screen here, I really don't care about this JSON stuff. I'm not interested in that. I want to see what actually happened when the program ran. And if I look at the terminal, I see that, yes, indeed, hello world was displayed. This other stuff here, the one symbol and done and blah, 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 that's the actual command line in Linux that Visual Studio Code executed in order to compile and run the hello program. Now, in this terminal, this is a shell terminal, and I can use my ls command to see the list of files that I have. Here is my source code file, and by default, Visual Studio assumes that I want the executable program to have the same name, but without the .cpp extension. It turns out that in Linux or Unix, there is no separate extension for executables, such as .exe or .py or .com or what have you. The typical thing in Unix or Linux is that the name of the executable program is just the name of the source code file with the extension chopped off. Now, I can execute hello by just typing its name. Aha! Except that my path apparently does not contain the current directory. And so hello was not found by my shell. Consequently, I need to tell the shell exactly where this file is by typing the name of the current directory and then a slash and the name of the file. Now, as with Windows, the name of the current directory is dot. Okay, you may not even be consciously aware of this, but this is a thing that Windows borrowed from Unix way back when. The name of the current directory is dot, and so if I say ./hello, that explicitly tells the shell to look for the hello program in the current directory, and yay! It executes. So I see hello world, and then there's a new line character so that the prompt comes out on the next line down. All right, let me demonstrate that new line matters. If we eliminate the new line character and rerun, this is going to rebuild the code. And notice that hello world here has come out with no new line after it. In fact, I can say well, let me list my files just to confirm. Okay, so I've listed my files, and the name of the executable program is hello. So if I say ./hello, you see there's no new line. The prompt comes out immediately following the D in hello world. All right, so that new line really matters. Let me put the new line back, and I will save the file. File, save. Now, I can go back up and do the run without debugging. I just want to demonstrate that you can execute them. You can execute the compiler outside, well, not using the run menu. You can say G++, that's the name of the compiler, and the name of your source file, hello.cpp. And then, to specify the output executable file name, use an option -o, followed by the name that you want the executable file to have. This is basically what all of that JSON stuff is setting up internally. And since I got no error, it must have worked. And I can now execute hello. Remember that I had added the new line back. So there we are. Okay. When we quit from Visual Studio from within WSL, we get back to our Ubuntu terminal, and Visual Studio will remember what I was working on most recently. So if I say code prog1 again, Visual Studio restarts with the same access to the same files and so forth that I had before. Okay, Well, that was rather lengthy, but we finally got this thing all installed and tested and working.